So good morning, dear students. I hope my screen is visible to you and I am audible to you. Today's our agenda is to revise the unit number 1. And in the last class, we have finished the unit number 3, part B, that is the condition monitoring of the electrical equipments. So in 2 minutes, we will quickly revise the things what we have discussed in the last lecture. We are interested for the condition monitoring, and one can say that what is the condition monitoring? So we have to check or you can say we have to carry the routine checkups for our electrical equipments, and we have to test or we have to measure certain parameters. So that is nothing but condition monitoring. And I told you the conclusion of the condition monitoring is that whenever we are interested for 100% condition monitoring, it means if we are doing the 100% condition monitoring, it means there is a less chances, or you can say 0% fault is going to occur. So that is an important conclusion for the condition monitoring. Yes. So we have to make sure that we are interested for 100% condition monitoring. Then and then only we can say there is a less chances, or you can say there is a 0% chances are there that fault is going to occur. That we have discussed. After that, we have discussed some important, or you can say the standard techniques to carry out the condition monitoring. So what are the techniques or standard techniques are available? So one can say the vibration analysis is a first technique. The second technique is the oil analysis. So the second technique is related to the checking of oil. The third technique is the thermal images. So the thermal analysis we need. And the fourth technique is related to ultrasound analysis. So these four techniques are used as a standard for the condition monitoring. And we are interested for the thermography cameras or thermography images. So that we have discussed in the last class. Yes. You know that whenever there is a system, obviously there are advantages and disadvantages. So the advantages of the thermography analysis is it is a non-contact operation. That is an important operation, or you can say that is an important advantage. Non-contact. Yes. Rapid, you can say scanning is available. So that is again the second advantage. The third advantage is we can store the images in any format. That is a again very much advantageous. And the fourth advantage is these images are reliable. One can believe on these images and they can start the checking or they can start the maintenance. So obviously these are the advantages of the thermography cameras or the thermal images analysis. There are disadvantages. So disadvantage number one is obviously the cost is very high. So that is an important disadvantage of the thermography camera. And the second disadvantage is what? We cannot measure the, you can say, the inside temperature for the glass material, or you can say polythin material. Yes. So this is the disadvantage of the thermography images, or you can say the thermal images. Yes. So we cannot measure the inside temperature where the glass material is available. So I have summarized the revision in the chat box. So those who have just joined, they can read the chat box and they can understood the revision of the last class. Yes. Now you can see over here in the screen, this is our unit number 1. And this unit plays an important role for your in-semester exam. And the paper of EIMT is on, I guess, on 16th of October. There is a paper of EIMT. It is of 1 hour from 10 to 11. And that can be the online mode. Those who have selected the offline mode, they can have to appear to this particular center and they can write the paper. But I guess many of the students from your class have selected the online as an option. Yes. But if you are facing any difficulty while writing the exam. So the system is very proof. Yes, तुम्हाला गाईडलाईन्स दिल्या जातील की तुम्हाला पेपर कसा लिहायचा आहे. कॉपी शक्यतो करणं टाळा, कारण की ऑनलाईन रेकॉर्डिंग असेल, व्हिडिओ तुमचा कॅमेरा ऑन ठेवायला सांगतील तुम्हाला. येस, आणि तुमची जर थोडीशी जरी हालचाल झाली तुम्हाला ट्रबल होऊ शकतो. येस, so make sure that 1 hour you have to sit at one place where there is a range available, network available, and before that, appearing for the exam, you must take care of the revisions of all the 3 units. Yes, now we will start with the revision. We are having the limited time for the revision, but before starting the revision, I want to show you the in-semester exam paper for your EIMT subject. Obviously, the paper starting from 12th of October is the, you can say, the online paper. So there are maximum chances that the MCQ are going to appear. But make sure that if there can be a theory question, so you can able to write in a systematic way, and maximum you can say चांगलं लिहिलं म्हणजे छोट्यातल्या छोट्या गोष्टी जर लिहिल्यात पण त्या इफेक्टिव्ह लिहिल्या, सो यू विल कॅरी द मार्क्स. येस, so this is the EIMT question paper. So you can see over here the time is 1 hour and the maximum marks are 30. So this is the in-semester paper. So we will quickly see what can be a question is asked for you also and for the previous batches also. So this is the first question. Explain the factors needed to be considered in design of distribution feeder. So we have studied these factors. Yes, we will just see the question type, or you can say the difficulty level of question, and then we will quickly revise the unit number 1. Yes, so हे क्वेश्चन पेपर्स हे सगळे अपलोड केलेले आहेत तुमच्या गुगल क्लासरूम मध्ये. जर वेळ मिळत असेल तुमच्या बिझी शेड्यूल मधून तर ते अवश्य बघा, जेणेकरून यू विल गेट कॉन्फिडन्स to write the exam of EIMT subject. Yes, and believe me, EIMT subject is a subject in which you can score out of marks. So if you are going to write point wise, if you are going to write systematic way, then you will surely score out of marks. Yes, so this is the first question. Explain the factors needed to be considered in design of distribution feeder. So here is a question. What is a feeder? Feeder is nothing but it is a conductor which is used for connection of substation to particular area that we have known. Yes, that is called the feeder. But here they have asked what are the factors. We know that for design of distribution feeder, there is a one important factor that is called the constant current carrying capacity. So I told you the small concept or small trick. You have to remember this F stands for feeder and C stands for the current carrying capacity, constant current carrying capacity. So FC you have to remember. Yes, so this is the first factor to be considered for design of distribution feeder. Then you can write the explanation of the what is the meaning of current, why there is a need of current. Whenever you are going to provide the voltage, there is obviously the effect of current is available. Yes, so this is the first factor. What is the second factor? The second factor is related to the, you can say, the load condition. Yes, so the maximum availability of the load, that is called as a the design consideration for particular feeder. After that, one can say the cost is also one factor. Yes, so at least you can write the 4 factors, and if there is an explanation is going to ask, then you have to explain that point in a systematic way, so that your time will save and you will get a full marks. Yes, the second question is how the economic choice of conductor size can be made using Kelvin's law and write its limitation. Yes, so we have seen the Kelvin's law also. So what is the Kelvin's law? Kelvin's law is nothing but it is used for finding out the economic choice of conductor size. And if we are interested for the Kelvin's law, so we have to remember one equation. What is that equation? The equation is nothing but the cost which is used for installing or for erecting the towers is equal to the loss which is occurred in that particular tower or particular line. So that should be balanced. That is nothing but the Kelvin's law. Obviously there are limitations. So limitations are nothing but we cannot use this system for you can say the double circuit line. So this can be a limitations of the Kelvin's law, and we cannot get the actual economic size of conductor for this particular Kelvin's law. Yes, मी तुम्हाला फक्त याच्यामध्ये एक ओव्हरव्ह्यू दाखवतो आहे. ज्यावेळेस आपण रिव्हिजन घेऊ त्यावेळेस आपण परफेक्टली याचा स्टडी करू. येस, अँड दिस इज द सेकंड A question. So obviously there is a numerical is asked, and the numerical is based on the power factor at receiving end. तुम्हाला कळत असेल की आपण हे एक्झाम्पल घेतले होते. येस, आणि सेम एक्झाम्पल आपण तुमच्या ज्या नोट्स आहेत त्याच्यामध्ये पण अवेलेबल करून दिलेले आहेत. What is the question? A single phase AC distributor AB is 500 meter long. Distributor is fed from point A and is loaded as 100 ampere at 0.707, lagging power factor at 300 meter at C from A. म्हणजे तुम्हाला AC ची साइज ही किती आली? 300 आली. ऑब्वियसली C पासून B पर्यंत साइज असेल 200 मीटर. 200 ampere at 0.8 lag power factor at 500 meter from point A. म्हणजे A पासून तर तुमचा पॉइंट हा B आहे तो 500 मीटर लॉंग आहे. Yes, so this is the 500 meter long. Obviously, there are current ranges 100 ampere for point C and 200 ampere for point B. Yes, the power factor at both the load points are referred to voltage at far end. So this is the important, you can say, identification of the case. Voltage at far end. It means it is at receiving end. The total impedance they have given, Z they have given 0.2 plus J 0.1 ohm per kilometer, and what we have to calculate? We have to calculate the total voltage drop. Yes, so this same numerical is available in your notes. We will try to take this numerical also today. Yes, so and the second question is explain the following supply system in distribution. So obviously there is a derivation of single phase 2 wire AC system and 3 phase 3 wire AC system. So this is the question of 10 marks from unit number 1. Obviously 10 marks question from unit number 1, 10 mark question from unit number 2, and 10 mark question from unit number 3. So that is the distribution of 30 marks. Yes, but we don't know what will be the distribution for your online exam. Yes, so this is a tentative distribution for unit number 1. Yes, and this is the paper of the end semester exam. So we will see just in 2 minutes. So obviously there is a numerically is asked, and the same numerical which we will take today. Yes, so they have given the conditions of loading, and we are interested to find out the voltage at sending end and phase angle between the voltage. Yes, the classification of supply substation. So this is from unit number 2. Determine or define the polarization index and dielectric absorption ratio. So this is from unit number 3. Yes, obviously there is a, you can say, the find out the most economical size as per the Kelvin's law. The numerical is asked. Yes, explain the pipe earthing from unit number 2, and faults that occur in induction motor. What are the causes? So this is the faults we are interested for side the stator as well as rotor. Yes, and what are the causes? So only the numerical is asked from unit number 1. Yes, so this numerical and this numerical. Yes, now this is the third question paper. The third question paper is also the end semester exam. So they have asked compare. Now we are interested for comparison of 3 phase 4 wire AC system for the underground. Yes, with 3 phase 3 wire on the basis of volume of conductor required. So we are interested for 3 phase 4 wire AC and 3 phase 3 wire AC system. So that we have to compare for 8 marks. Yes, same question, state and explain the Kelvin's law and state limitations of Kelvin's law. So you can understood from unit number 1, Kelvin's law is very important. So you have to try to understood or understand the statement, and after that there is a derivation. Yes, and this is the thermography concept they have asked from unit number 3. Now we will go for unit number question number 2. So again there is a question of numerical. We are interested for finding out the voltage drops at VS and VB. Yes, so same question. State the different types of maintenance strategies. So breakdown and preventive maintenance. So this is from unit number 3A, and state the objective of neutral earthing. Yes, so 8 marks will be asked for your end semester exam. Okay, so this is the overview of question papers. Now we will start with the revision. I hope now you are aware about what are the questions can be asked from unit number 1. So this is the unit number 1 syllabus, and believe me, this point is a very important. So that point is nothing but the Kelvin's law. So I want to highlight this point. So this point you have to do very clearly. After that, you have to do the comparison of this very clearly. Yes. And after that, we are interested for this numerical. Yes. So this numerical we have to do. And this is the simple concept, design consideration of distribution filter, radial ring. Yes. So these 3 points carries a maximum weightage from this unit number 1. Yes. ही इम्पॉर्टंट गोष्ट आहे युनिट नंबर 1 मधून, आणि ही तुम्हाला करणं गरजेचंच आहे. येस, कुठेही काही गोष्ट और टाकू नका, कारण की याचा त्रास तुम्हाला एंड सेमिस्टरला होईल. ठीक आहे. नाउ वी विल रिवाइज द थिंग्स. येस, I hope the screen is visible to you, and these notes are already uploaded on the Google Classroom for the EMT subject. So first you have to download the notes and you have to start the preparation. Yes. So the first difference is very simple: DC transmission and AC transmission. And because of this difference, one can understood that we can use the AC transmission maximally because our load is AC and our generation is AC. Yes, so this AC transmission we are using, but no doubt recent areas or recent trends are showing that DC transmission is also effective or efficient. Yes, but in India we are maximally using the AC transmission. So this is the comparison. Yes, after that we are interested for the various systems for power transmission. कुठेही घाई वाटत असेल तुम्हाला, कुठेही तुम्हाला त्रास होत असेल ऐकण्याबद्दल, तर मला लगेच कळवा. स्क्रीन दिसत नसेल तरी तेही मला कळवा, जेणेकरून मला लगेच समजेल. येस, आणि रिव्हिजन म्हटल्यावर थोडं मला घाई करावीच लागेल. येस, व्हेरियस सिस्टम्स ऑफ पॉवर ट्रान्समिशन आर, देर आर, यू कॅन से 4 systems are available: DC system, single phase AC system, 2-phase AC system, and 3-phase AC system. So these 4 systems are available, and believe me, they are going to ask for you the 3-phase 3-wire and 3-phase 4-wire difference comparison. Yes. So what is our procedure? Our procedure is to compare the conductor material in overhead system first. After that, same comparison is available for underground system, and then we are going to take the final volume of conductor material, and then we will make the conclusion. Yes. So the first system is very simple: DC 2 wire with 1 conductor earth. कदाचित तुमच्या व्हॉट्सअप ग्रुपवर मी एकदा प्रोसिजर टाकली होती ह्या प्रोसिजर म्हणजे हे डेरिव्हेशन करण्याची. हाऊ टू डिराइव्ह दिस डेरिव्हेशन? ऑब्वियसली यू हॅव टू ड्रॉ द सर्किट डायग्राम फर्स्ट. डीसी मोटर आहेत, डीसी सिस्टीम असल्यामुळे वी हॅव टू यूज द VM. ऑब्वियसली वी नीड द कंडक्टिंग वायर्स विच कॅरीज द करंट, and with 1 conductor earth, so we have to make 1 conductor earth. So this is the DC 2 wire with 1 conductor earth system. Yes. Now we have to take the VM as a maximum voltage. So VM stands for maximum voltage. The power is transmitted is P. So we know that whenever we are using the power application, the voltage is available, and because of voltage there is a current is available. Yes. So if we are interested to find out the current I1, so I1 is nothing but P upon VM. So this is the important calculation of load current that we know. After that, we are interested for the specific resistance, or you can say the law of resistance, R1. R1 equal to rho L by A. And what is A? A is nothing but it is a cross section of conductor. Now what is the line losses? W. W is 2I square R. So for 2, we are using the 2 conductors. If we are using a 3 conductors, then we have to take the 3I square R. That is for the line losses. Now put the value of I, P upon VM, put the value of R as rho L by A. Solve this equation and try to find out the area of conductor. So A equal to 2P square rho L divided by W VM square. इथपर्यंत आपलं काम झालेलं नाहीये. आता आपलं काम काय आहे? volume of conductor material required काढायचा आहे. And what is the volume of conductor material required? 2 times AL. 2 conductor असल्यामुळे 2. जर 3 असतील तर 3. Yes. Put the value of this A. Put the value of this L. Yes. And after this, you will get this equation. 4p square rho L square divided by W Vm square. And we have to make sure that we are using this term as K. Yes, because we have to make one parameter for comparison. So this is for the DC 2 wire with one conductor earth. Same way we have to apply for single phase 2 wire AC system. So if we are going to consider the AC, we have to take the AC load. So the inductor is used, the VM is used, the 2 conductors are used, and 1 conductor is earth. Same way. But whenever we are going to consider AC, we have to use the RMS value. VM divided by root 2. So that is the RMS value. Yes. After that, whenever there is a AC, there is a power factor, cos phi. So for this load current I can be P divided by VM divided by root 2 into cos of phi. What is the next procedure? The resistance which we are interested. So we can write the resistance equation as R equal to rho L by A here, or we can write directly the line losses W equal to 2I square R. Put the value of I, this, put the value of R as rho L by A. Try to find out the A area of cross section from this equation, and after that, volume of conductor material required is a very important. What is the volume of conductor material required equation? It is same, 2 times AL. Put the value of A and put the value of L. Yes, so this is the equation we will get finally. But this value 4p square rho L square divided by W Vm square cos, this value is K. So K times 2 divided by cos square phi. So that is a comparison. Third, 3-phase 3-wire AC system. It is important for the overhead system as well as for the underground system. So whenever we are going to consider the 3-wire, obviously we need the star connection. Yes. Whenever we are going to carry the star, obviously there is the availability of neutral. The middle point indicates the neutral point. We have to take the voltage between the 2 phases is Vm. Yes. So here the neutral N is earth for using the balance load. Now what is the value of RMS? Vm divided by root 2. And what is the power transmitted per phase? So for the 2 wire, we are not using P divided by 2. It is the same, P. But for the 3 wire, we have to divide P divided by 3. But we know that P divided by 3 equal to Vi cos phi. Put the value of I as T into root 2 divided by 3 Vm cos phi. So this is the multiplication of your RMS voltage per phase. Now we have to use the W equal to 3I square R. आता तुम्हाला कळत असेल इथे 3 कशामुळे घेतलाय? 3 वायर असल्यामुळे. Put the value of I as P into root 2 divided by 3 Vm square Vm cos phi. याचा स्क्वेअर करायचा आणि R ची व्हॅल्यू यू कॅन राईट डायरेक्टली रो L by A. इथून परत तुम्हाला A काढायचा आहे. A काढण्यासाठी यू हॅव टू मेक द रिअरेंजमेंट. रिअरेंजमेंट करताना किंवा इक्वेशन रिफॉर्म करताना कुठेही टर्म स्किप करू नका. 2 मिनिटं जास्त गेली चालतील पण तुमचा वेळ हा वाचेल. ठीक आहे. अँड दिस इज द व्हॉल्यूम ऑफ कंडक्टर मटेरियल रिक्वायर्ड 3 times AL. Put the value of A, this, put the value of L, and try to rearrange the term in terms of K. So it comes as 0.5 times K divided by cos square phi. Now the case will be 3-phase 4-wire AC system. We know that we are using a 3-wire system, and this 4-wire is we are not going to make the earth. In the 3-phase 3-wire, we don't need this 4-wire, so we have made this earth, and from this the current will be 0 for 3-phase 3-wire. But here there is a 4th wire is available, so it is not earth, so there is a possibility of current is going to flow. Yes. So we will take the system reduces to 3-phase 3-wire. How? If we are going to consider the loads are balanced. तुम्हाला कळत असेल आता की इथे मी अर्थ केलेलं नाहीये. अर्थ कुठे केलं होतं मी? 3 फेज 3 वायर मध्ये अर्थ केलं होतं, म्हणून मी ती स्किप केली होती. पण इथे जर 4th वायर अवेलेबल असेल आणि जर मी बॅलन्स सिस्टीम ही कन्सिडर केली, म्हणजे याची व्हॅल्यू आणि याची व्हॅल्यू ही सेम असेल, सो ऑब्विसली द करंट फ्लोइंग थ्रू न्यूट्रल इज 0. सो दिस सिस्टीम इज रिड्युसेस टू 3 फेज 3 वायर. तुम्ही डायरेक्टली इक्वेशन हे कॅरी करू शकतात एचं. म्हणजे तुम्हाला पहिले पी काढावं लागेल, p/3, आय काढावं लागेल. आय काढल्यानंतर तुम्हाला व्हॅल्यू पुट करावं लागेल डब्ल्यूची व्हॅल्यू ही काय असेल? 3I²R असेल. After this, rearrange the term A and you will get the A value. Now, we know that as the area of cross section of neutral wire is 1/2 that of the line conductor, so we have to add that 0.5 for the line conductor. 3 plus 0.5, it comes as 3.5. 8 times AL. Put the value of A, this, put the value of L. Rearrange the terms and you will get the final equation as 7 times K divided by 12 cos square phi. So divide 7 by 12, 0.583 times K divided by cos square phi. Yes. So this is for 3 phase 4 wire AC system. Same way you can go for underground also. Procedure same असेल. तुम्हाला मी फक्त एकदा रिव्हिजन करण्यामध्ये माझा उद्देश हाच आहे की काही लोकांनी क्लास मिस केला असेल, काही लोकांनी क्लास स्किप केला असेल, गोष्टी आठवायला थोड्या जड जातात. येस, फॉर दॅट रिझन दिस इज अवर क्लास. येस, नाउ फॉर द DC 2 wire system, same way, this is for the underground. We have to draw the diagram. We have to take the current I. We have to use the WI²R. W equal to 2I²R because 2 is the 2 wire system. Put the value of I, this. Put the value of R directly, rho L by A. Area of cross section, we have to find out. This A we have to find out by rearranging terms. And volume of conductor material required is 2 times AL. Put all the values, get the answer, and give the name this as K. Now the second system is single phase 2 wire AC system. Now the AC is available, so you have to use the AC load. Obviously VM is available, so RMS value becomes VM divided by √2. Power factor is also available as AC system is available, so P equal to VI cos phi. Rearrange the term I equal to P upon VM by √2 cos phi. Use the formula W equal to 2I²R. Put the value of I as this much. Put the value of R as rho L by A. Solve the equation, find out the value of A and put the value of this in twice of AL, because they are interested for volume of conductor material required. So this is the final equation for single phase 2 wire system. The 3 phase 3 wire system, same way we have to draw the diagram. Here we are using the RMS value per phase, VM divided by √3, and for this VM divided by √3 we have to multiply with √2 to find out the RMS value, because this is a maximum and we are interested for per phase value. So firstly we have to divide by √3 and maximum value we have to convert by multiplying by √2. So this is the RMS value. Take the product of √3 into √2, it becomes √6. Power transmitted, obviously P/3. So use this equation P/3 VI cos phi. All the values put here, you will get the I. Then line losses 3I²R. Put the value of this I, put the value of R as rho L by A and solve the equation. Find out the value of A. इथपर्यंत काम तुमचं संपत नाही. पुढे काम तुमचं आहे volume of conductor metal required 3 times AL. Put the value of A, solve the equation in terms of K. 1.5K divided by cos square phi, and the last is 3 phase 3 wire, 3 phase 4 wire system. Obviously this is a balanced, so it will reduces to 3 phase 3 wire. Directly you can take the A. Yes, obviously there is a neutral wire is available, so we have to add that 0.5, so it becomes 3.5 times AL. put the value of A and try to solve the equation in terms of K. So this is the 3-phase 4-wire for underground system. आपल्याला एवढं रिव्हिजन करायला 15 मिनिटं लागले बरं. Yes. Now the next point is the comparison. So this is the summary. This is the chart. Here you can see these are the systems. This is the overhead system and this is the underground system. For the DC 2-wire system, the comparison is same. One factor we are getting. For the single phase 2-wire system, the factor is 2 divided by cos square phi. The factor is same, 2 divided by cos square phi. For overhead also, for underground also. For the 3-phase AC system, we will get the important comparison. For overhead, it will be less. For underground, it will be high. For the 3-phase 4-wire, we will get for the overhead 0.583 divided by cos square phi, and for the overhead, for the underground, sorry, we will get 1.75. So you can identify that 3-phase 3-wire and 3-phase 4-wire AC system is used for overhead transmission. It's a conclusion झालं आपलं. Yes. आणि तुम्हाला सांगितलं होतं मी की 3-phase 3-wire system is used for transmission purpose. मी तुम्हाला क्वेश्चन विचारतील MCQ मध्ये, which distribution system or which transmission system is used for AC system? So your answer is 3-phase 3-wire. But for the AC distribution system, we are using 3-phase 4-wire system. हा ट्रान्समिशन साठी आहे आणि हा डिस्ट्रीब्युशन साठी आहे. बिकॉज वी नीड द 4th कंडक्टर फॉर डिस्ट्रीब्युशन. तुमच्या घरामध्ये आहेत ना न्यूट्रल वायर, न्यूट्रल वायर या 4th कंडक्टर मधून येते. सो दॅट इज अ पर्पज ऑफ डिस्ट्रीब्युशन सिस्टीम. परफेक्टली हा क्वेश्चन तुमच्या MCQ मध्ये असेलच. येस. आणि हा क्वेश्चन कुठेही चुकता कामा नये. शुअर मार्क्स आहेत, कुठेही चुकता कामा नये आपण. ठीक आहे. नाउ द नेक्स्ट कन्सेप्ट इज the distribution system. So in a 2 minute, I'm going to explain you this concept. So this is a simple diagram. You have to write or you have to draw the substation S. You have to use the area A, B, C, D. Try to connect the area and substation together, which forms the feeder. What is a feeder? Feeder is a conductor which connects the substation to area where power is to be transmitted. Generally, no tappings are taken. And what is the design consideration? Constant current carrying capacity. That is a important consideration. Now, whenever we are going to connect the areas together, it forms a distributor. Let's say A to B, B to C, C to D, D to A. It forms a distributor. Yes. What is a distributor? Distributor is also a conductor from which tappings are taken for supply to consumers. So AB, BC, CD, DA are the distributors. Main consideration is what? Voltage drop capacity. That you have to remember. For the distributor, voltage drop capacity is used. And for the feeder, constant current capacity is used. And whenever we need the distributor, and from the distributor there are tappings available, and these tappings are called as service mains. तुम्हाला कळत असेल तुमच्या घरामध्ये जो कंडक्टर येतो ना ब्लॅक कलरचा, that is called as a service mains. And whenever we are using the service mains, that is the conductor which connects the distributor to our home. That is called as service mains. So this is related to distribution system. So there might be a question for you. Following are the components of the distribution system. Option 1, feeder. Option 2, distributor. Option 3, service mains. And option 4, all of the above. So the answer is all of the above. These 3 components are needed for forming the distribution system. Yes. So this is related to this page. The next part is classification. आपण distribution system बघितली, आता आपल्याला classify करायचं आहे. How to classify? Obviously, nature of current is there. AC DC is available. Yes, we know that AC distribution is economical and it is universally adopted because it is simpler. For the AC distribution, we can take the primary distribution and secondary distribution. For the DC, there is a 2-wire and 3-wire DC are available. This is for the nature of current. There is a type of construction can be available, overhead and underground. Which is perfect? No one can say, no one is perfect. Depending on the advantages, we are going to choose the system. The third scheme is depending on the connection. Radial, ring and interconnected. We will see the primary distribution system. तुम्हाला मी डायग्राम दाखवली होती बघा, ही डायग्राम आता इथे क्लिअर नाहीये, पण ज्यावेळेस मी लेक्चर घेतलं होतं त्यावेळेस मी तुम्हाला डायग्राम दाखवली होती की प्रायमरी डिस्ट्रीब्युशन सिस्टीम मध्ये वी आर युजिंग अ 3-phase 3-wire system which is go to substation, and after going to substation it will convert it into 33 divided by 11 kilovolt. So here you can see 11 kilovolt is transmitted, and where it is a need 11 kilovolt कुठे लागतं? इंडस्ट्री मध्ये, वर्कशॉप्स मध्ये. Yes, 11 kilovolt is needed. So one can say primary distribution is used for consumers, or you can say big consumers. Industry साठी लागतं. Yes, so this is the application of primary distribution, big consumer factories. What is the secondary distribution? ते 11 kilovolt आलं असेल ना, त्या 11 kilovolt ला मला 400 volt मध्ये करायचं आहे. That is the secondary distribution, and here you can see the delta star transformer is available. 3-phase delta star transformer is available. There will be the question for you. Which transformer is needed for the secondary distribution system? So your answer is 3-phase delta to star transformer type is needed. जर तुम्ही चूक केली इथे तर तुमचे मार्क्स हे लूज होतील. कुठेही चूक करता कामा नये. शांत डोक्याने डायग्राम आठवण्याचा प्रयत्न करायचा. सरांनी जे शिकवलं असेल किंवा आपण जे वाचलं असेल किंवा आपण जे ऐकलं असेल ते विश्वास ठेवायचा आणि त्याच्यावर आन्सर टिक करायचे. येस, obviously why we need the 400 volt? Because we are using our homes, we are using our industries, we are using our factories. Yes, छोट्या फॅक्टरी असतात ना, त्यांना 3-phase लोड लागतात. Yes, so this is the application of secondary distribution. Now we will go for radial. What is the radial? Radial is a simple, only one substation is available, and there are different feeders are going to take place from this substation. From this feeder, there is a distributor is available, and these are the loads which can say for our homes are available. So here you can see a single line diagram of radial system for DC distribution. OC supplies the distributor AB at point A, and this is for AC distributor. AC distributor तुम्ही कसा ओळखला? इथे ट्रान्सफॉर्मर आहे. काही लोकांचे डोळे चांगले असतील तर त्यांना ही गोष्ट लवकर दिसेल. ठीक आहे. Whenever we are considering the AC distributor, obviously there is a need of transformer, because in DC we cannot use the transformer, and this is called as radial system. There are advantages and disadvantages. We are not going to discuss these advantages and disadvantages today. We are interested only for the concept. The second concept is ring main system. Obviously there is a need of ring. Primary ring is available, and this ring is connected with one substation. एक सबस्टेशन आहे, सबस्टेशनला एक रिंग कनेक्टेड केलेलं आहे, आणि त्या रिंगला मी डिफरंट फीडर्स हे यूज केले आहेत. तुम्हाला कळत असेल की आता इथे ट्रान्सफॉर्मरचा सिम्बॉल काढलाय सरांनी, म्हणजे ही कोणती सिस्टीम आहे? एसी रिंग मेन सिस्टीम. येस, अँड व्हॉट इज द ऍप्लिकेशन ऑफ रिंग? इफ देयर इज अ फॉल्ट ऑन वन पर्टिक्युलर फीडर, then you can transmit or you can transfer the power from other end, either from this end or either from this end. Yes, so this is the application or advantage of ring main system. Third system is the interconnected system. Interconnected means we have to connect the two substations together, S1 and S2, with the help of one ring arrangement. Yes, so obviously there is a need of transformer, so this is the AC interconnected system. Okay, and what is the advantage? If the one substation is under the maintenance, so we can transmit the power from second substation. तुम्हाला विचारतात क्वेश्चन बऱ्याच वेळा MCQ मध्ये, which system we are using for connection of two substation? The answer is interconnected system we are using for connection of two substation. So this is for this interconnected. The next part is the design consideration of feeder. So this question can be asked. What are the different or following are the design consideration of feeder and distributor? So option 1, economy. Option B, reliability. Option 3, ability on demand. Option 4, proper voltage. Option 5, growth of load. And option 6, all of the above. So your answer is all of the above. These economic considerations are needed for design of any feeder or any distributor. So it is applicable to feeder as well as distributor, both. Economy, ऑब्विसली बजेटसाठी आपण त्याला चिंतित असतो नेहमी. रिलायबिलिटी, ती गोष्ट रिलायबल असली पाहिजे, त्याच्यावर आपण विश्वास ठेवला पाहिजे. कंटिन्युटी ऑफ सप्लाय इज अवेलेबल. अवेलेबिलिटी ऑफ डिमांड मीन्स व्हॉट, जेवढा डिमांड तिथे गरजेचा आहे तेवढा त्याने कॅरी करणं गरजेचं आहे. प्रॉपर व्होल्टेज विथ इन इंडियन इलेक्ट्रिसिटी रूल प्लस ऑर मायनस 6% इंडियन इलेक्ट्रिसिटी ऍक्ट 2001 दॅट यू हॅव टू रिमेंबर. अँड ग्रोथ ऑफ लोड. अर्बनायझेशन अँड इंडस्ट्रियलायझेशन मध्ये ते फीडरने तेवढं वेट किंवा तेवढं लोड हा कॅरी केला पाहिजे. सो दिस इज द डिझाइन कन्सिडरेशन. दिस इज द एक्सप्लेनेशन. यू कॅन रीड ॲट युअर ओन. येस. द नेक्स्ट पार्ट इज द साइज ऑफ फीडर, व्होल्टेज ड्रॉप्स अँड एनर्जी लॉसेस. सो these are the three size of conductor to be needed, or for finding out the size, obviously we need the current carrying capacity, we need the voltage drop capacity I into R, and we need the overall economy. its cost पण काय पाहिजे, कमीत कमी पाहिजे. Yes, so these are the size of feeder, voltage drops and energy losses in the feeder parameters आहेत हे. Yes, so these are the parameters. The next question is the AC distribution system. आता तुमचं डिफिकल्टी पार्ट सुरू झाला बरं. Power factor referred to receiving end. So that we have to draw the diagram. This is the incoming. So incoming चा symbol दिसत असेल तुम्हाला A, C and B. At C point there is a I cos phi 1 and at B point there is a I2 cos phi 2. Obviously we have to make R1 plus JX1 and R2 plus JX2 for AC and CB respectively. After that we are interested for impedance for section AC. ZAC equal to R1 plus JX1 and ZCB equal to R2 plus JX2. And how to write the I1? I1 we can write in terms of vector with the combination of cos phi and sin phi. I1 is related to phi 1 and sin phi 1, and I2 is related to cos phi 2 and sin phi 2. Now we are interested for current in section AC, total I1 plus I2. Take the addition of these two. Yes, and if we are interested for ICB, so ICB is nothing but I2, so that we have to carry. After that we are interested for voltage drop. And what is the voltage drop? Voltage drop is nothing but it is a product of current flowing through that particular component into the impedance. For the case of AC, alternating quantity असेल तर तुम्हाला impedance घ्यावा लागेल. I1 plus I2 into Z times AC. Put the value of these two parameters, solve this equation, and you will get your final equation of voltage drop. What is the voltage drop in CB? Obviously we take the current flowing through CB and impedance flowing through CB. So take the ICB component, take the ZCB component. And इथे बघितलं तुम्हाला क्वेश्चन बघितला होता आपण की सेंडिंग एंड व्होल्टेज विचारलं होतं. मग सेंडिंग एंड व्होल्टेज जर विचारलं आणि जर तुम्ही म्हटलेत की सरांनी शिकवलं नाही तर हा खूप माझा अपमान होईल. हेन्स यू हॅव टू रिमेंबर दिस फॉर्म्युला VA इक्वल टू ऍडिशन ऑफ ऑल द व्होल्टेजेस VB प्लस VCB प्लस VAC. Yes, and what is the sending end current? The combination of two components I1 plus I2. So this is for power factor or voltage at receiving end. Voltage or you can say power factor to respective load. So same diagram काढायची आपल्याला. त्यासाठी सुद्धा here there is a small change. What is the change? I2 ZCB we have to take. I2 ZCB component we have to carry same. At point C we have to use. आता आपल्याला काय करायचं आहे, त्या पॉइंटला पॉवर फॅक्टर हा कन्सिडर करायचा आहे. आपण आतापर्यंत काय केलं होतं, रिसिव्हिंग एंडला आपण पॉवर फॅक्टर कन्सिडर केला होता सगळ्यांचा, आणि आता आपल्याला त्याच पॉइंटला पॉवर फॅक्टर कन्सिडर करायचा आहे. So for this VC at an angle of alpha, you have to consider I1 can be written as I1 at an angle of minus phi1, and minus phi1 you can write in terms of alpha minus of phi1 minus alpha. Put the value of I1 as cos in terms of phi1 minus alpha minus j times sine of phi1 minus alpha, and take the addition of this I1 and this I2 together. This I2 together, you will get your IAC. So this is for the power factor at respect to load voltages. तुम्ही एकदा परत तुमच्या हिशोबाने बघा आणि तुम्हाला नक्कीच ती गोष्ट कळेल. मला कधीही फोन करा, मला कधीही मेसेज करा, आय विल ट्राय टू आन्सर युअर क्वेश्चन. आणि थोडासा पेशन्स धरा. येस, असं नाही की मी लगेच मेसेज टाकल्यावर लगेच वाचेल आणि लगेच तुम्हाला रिप्लाय करेल. येस, थोडासा पेशन्स धरा, मी नक्की आन्सर देण्याचा प्रयत्न करेल. सो दिस इज द क्वेश्चन. बघा, हा क्वेश्चन डिसेंबर 15 ला घेतलाय. द क्वेश्चन इज व्हेरी सिंपल. वी आर इंटरेस्टेड फॉर फाइंडिंग आउट द टोटल voltage drops. So this can be a diagram A, C, B. The length is 200, 100, and this is the I1 at 100, I2 at 200, and cos phi1 at 0.707, and I2 on cos phi2 at 0.8 lakh. After that, we have to take the impedance per kilometer. They have given the value as 0.2 plus j 0.1. We are interested for ZAC. So we have to use this 200 meter. We have to convert into kilometer. आपल्याला ते किलोमीटर मध्ये कन्वर्ट करावं लागेल. त्यासाठी पर किलोमीटर काढायचं आहे ना आपल्याला. हेन्स we have to divide with 1000. So this is for ZAC. Same way ZCB can be calculated. So this is ZAC value and this is ZCB value. आणि ZAC ZCB मिळाल्यानंतर आपल्याला काय काढायचं आहे? I काढायचं आहे. What is I2? Use formula same. I2 cos phi2 minus j times sin phi2. cos phi2 हा त्यांनी दिला 0.8 2 च्या रिलेटेड. आणि मग तुम्हाला प्रश्न पडला असेल की सर phi2 दिलाय, cos phi2 दिलाय, sin phi2 थोडी दिलाय, मग cos phi2 वरून तुम्ही phi2 काढायचा आणि phi2 वरून तुम्ही sin phi2 काढायचा 0.6. टेक दिस, make the multiplication, you will get this answer for I2. Try to calculate for I1 also. So I1 is also same. Use the formula, put the answer, you will get the I1. I1 मिळाला, Z मिळाला. आता पुढची गोष्ट आहे तुमचं इम्पेडन्स काढायचा, सॉरी व्होल्टेज ड्रॉप काढायचा. पण व्होल्टेज ड्रॉपच्या आधी मी काय करेन, दोघांचे ऍडिशन करून टाकेल, I1 प्लस I2. दोघांचे ऍडिशन केल्यावर यू विल गेट दिस आन्सर. आणि लास्ट केस व्होल्टेज ड्रॉप ऍट फार एंड. टेक द मल्टिप्लिकेशन ऑफ करंट अँड टेक द मल्टिप्लिकेशन ऑफ इम्पेडन्स. सो यू हॅव टू सॉल्व दिस विथ द हेल्प ऑफ कॅल्क्युलेटर ओनली. कॅल्क्युलेटरवरच तुम्हाला सॉल्व्ह करावं लागेल. जर तुम्ही तोंडी करत बसले तुमचा वेळ जाईल, एक्झाम संपून जाईल, तरी तुमचा आन्सर येणार नाही. सो यूज द कॅल्क्युलेटर फॉर दिस. व्होल्टेज ड्रॉप इन सेक्शन CB, दिस, अँड व्होल्टेज ड्रॉप इन सेक्शन AC, करंट into impedance. So this is the standard procedure to solve the numerical. Yes, and the last point is the economic of power transmission. Economic of power transmission साठी मला सांगितलं होतं मी की Kelvin's law हा important आहे. And what is the Kelvin's law? Kelvin's law is nothing but the most economical area of conductor is that for which total annual cost of transmission line is minimum. This is known as Kelvin's law. And we can write annual charge on capital outlay. म्हणजे टावर्स असतात ना, टावर्स, ट्रान्समिशन लाईन, दॅट इज नथिंग बट कॅपिटल आउटले इज इक्वल टू अॅन्युअल कॉस्ट ऑफ एनर्जी वेस्टेड. हाच तुम्हाला मी मागाशी सांगितलं. आणि यांचं जर हे इक्वल असतील, सो दॅट इज कॉल्ड केल्विन्स लॉ. नाउ फॉर दिस यू हॅव टू राइट डायरेक्टली annual charge equal to P1 plus P2A, and P3 is a constant. Yes, you can write energy wasted equal to P3 divided by A. Yes, you have to take the addition of P1 plus P2A plus P3 divided by A. So use this constant for C. We are interested for the maximum value. So take the derivative at equal to 0. P1 plus P2A plus P3 divided by A equal to 0. P1 चा derivative 0. P2A चा डेरिव्हेटिव्ह P2 आणि P3 डिवाइड बाय A चा डेरिव्हेटिव्ह घात खाली लिहा, घातातून 1 वजा करा, P3 डिवाइड बाय A स्क्वेअर. P2 इक्वल टू P3 डिवाइड बाय A स्क्वेअर. सो P2 we have to segregate this A, P2A equal to P3A, and this is the variable part of annual energy charge is equal to annual cost of energy wasted. So that is another statement. So this is the Kelvin's law. One can represent the Kelvin's law with graphical method also. So we have to use the P1 plus P2A, one graph. This is the hyperbola, P3 divided by A, yes. And whenever we are going to take the intersection of these 2 points, we will get the third graph. And this is called as addition of these three. Limitations. It is not easy to estimate the energy loss in the line without actual load curve. This law does not take into the account several physical factors like safe current density, mechanical strength and corona loss. Corona वरून तुम्ही लक्षात ठेवू शकता की corona loss हा consider करत नाही. Interest and depreciation on capital outlay cannot be determined accurately. अजून 5 मिनिटं आहे. 5 मिनिटांमध्ये आपण एक न्यूमेरिकल फिनिश करू व्यवस्थित. And this is your revision of unit number 1. पेज नंबर 33 होते. 30 पेजला आपण पोहोचलो आहे. Yes. We will see the numerical slowly so that you can easily understood by reading the numerical. A 2-conductor cable 1 kilometer long is required to supply the constant current of 200 ampere throughout the year. The cost of cable including the installation is 200A plus 20 per meter. That you have to remember, per meter. Where A is the area of cross section in centimeter square. The cost of energy is 5 paise per kWh. Interest and depreciation charges are 10%. Calculate the most economical size of conductor. Assume the resistivity is 1.73 micro ohm centimeter. Numerical simple आहे. कुठेही गडबड गोंधळ करता कामा नये. ठीक आहे. What is the resistance of one conductor? Formula is very simple. R equal to rho L by A. Put the value of rho as same 1.73 into 10 raised to minus 6. L equal to आता तुम्हाला किलोमीटर मध्ये घ्यायचा आहे तो. So किलोमीटर साठी तुम्हाला you have to use 10 raised to 5 directly, or you can use 10 raised to 3 into 10 raised to 2. Yes, and this A is a constant. So after solving this equation, you will get 0.173 divided by A ohm. Obviously, it is a resistance. Unit is ohm. What is the next term? Energy loss per annum. This is constant. 2I square RT divided by 1000. हा per साठी घेतलाय आम्ही. Per kilometer साठी 1000 घेतलाय. Yes. kWh. Put the value of I as 200. R as this value 0.173 divided by A. T कसा काढला होता बघा. 365 days असतात. 365 days ला मी 24 ने जर मल्टिप्लाय केलं, I will get 8760 hours. Yes, because I am interested for hours. Yes. After solving this equation, you will get the energy lost per annum. After this, they have given the rate. So याला तुम्हाला रेट ने मल्टिप्लाय करावं लागेल. रेट किती आहे? 5 पैसे. 5 divided by 100. This is the equation number 1. Equation number 1 मिळालं. आता equation number 2 साठी, as the capital cost of cable is given to 20A per meter. 200 plus 20A बघितलं होतं आपण. 200 हा 0 होऊन जाईल कारण की डेरिव्हेटिव्ह काय असतो, कॉन्स्टंटचा 0 असतो. 20A चा डेरिव्हेटिव्ह काय असेल तुमचा 20 असेल, म्हणून ती फॅक्टर तुम्हाला कन्सिडर करावं लागेल. फॉर 1 किलोमीटर रेंज कॅपिटल कॉस्ट इज 20A into 1000. 1 किलोमीटरचा 1000 ला मल्टिप्लाय केलं, इट कम्स ॲज 20,000 A. नाउ द व्हेरिएबल अॅन्युअल चार्ज. आता अॅन्युअल इंटरेस्ट अँड डिप्रिशिएशन तुम्हाला सांगितलं तुम्ही. डिप्रिशिएशन म्हणजे काय? घसारा. किमतीतला घसारा ला तुम्हाला मल्टिप्लाय करावं लागेल 20,000 ला विथ द हेल्प ऑफ 10%. यू विल गेट 2000A. दिस इज द इक्वेशन नंबर 2. दोन इक्वेशन मिळाले, दोघांचा कंपॅरिझन करायचं. 20,000A इक्वल टू 6062A. A स्क्वेअर मिळेल, A मिळेल तुम्हाला 1.74 सेंटीमीटर स्क्वेअर. दॅट इज अ परफेक्ट युनिट फॉर द एरिया. आय होप यू अंडरस्टूड द केल्विन्स लॉ न्यूमेरिकल. छोटं न्यूमेरिकल तुम्हाला विचारू शकतात परीक्षेमध्ये. एवढं लांब लचक न्यूमेरिकल विचारणार नाही, किंवा एखादी मधली क्वांटिटी तुम्हाला विचारतील. बट फॉर अ सेफ्टी रिझन यू हॅव टू टेक द न्यूमेरिकल व्हेरी क्लिअरली. Yes, I hope you understood the unit number 1 part very clearly. And today, in 1 hour, we have to try to minimize the equation very clearly. Yes. Yes, Vishal, the question. Exam form. You have filled the exam form already, I guess, Vishal, or all the students have filled the exam form clearly. ओके सो तो पॉइंट माझ्या डिस्कसच्या बाहेरचा आहे. तर